Okay, good evening, Algebra 2 class. Today we are going to be going over three equation systems of equations. So the same principle applies. What we're going to try and do is isolate one variable, solve for that one variable, and plug it back in. It's the same thing we did with regular systems of equations. That is two variable systems of equations. So I don't have written down what numbers these are, but I think it's page 170, something like that, and it's 9 through 29 odd. Okay, so the first one we're looking at, these are the three equations. Now it says elimination here, so I'm going to do elimination. If you really wanted to do substitution, you could. I'm not. Later on, I'll do one both ways, just to show you that it can be done. But again, I told you guys this in class, once you've seen how to do it in substitution, once you've seen how to do it in elimination, you can pick your own way, whichever way works best for you. Frankly, you're going to get the same answer. So here, what I'm going to look at is what variables can I easily get rid of. And I see that there's that y in the middle. That y there's a positive y on the second equation, and then a negative y in both the first and the third equation. So what we're going to do is we're going to take those first two, x minus y plus z equals negative 1, and x plus y plus 3z equals negative 3. We're going to add them together. That's going to give us 2x plus 4z equals negative 4. Okay, so now we're going to put that on hold for a while. Then we're going to take our bottom two, we're going to add those two together. So we have x plus y plus 3z equals negative 3, and 2x minus y plus 2z equals 0. And we're going to add those together. So now we have 3x plus 5z equals negative 3. So if this doesn't make sense the first or the second time, go ahead and re-watch it. If it still doesn't make sense, come in during lunch, during academic overtime. We've got B-lunch. And, ask me, hey, Mr. Renard, can we go over another one? What I'd like to see, though, is that you guys try it first before just giving up and asking for help. So, now we have two equations, 2x plus 4z equals negative 4, and 3x plus 5z equals negative 3. And we're going to treat this, now this is just like systems of equations that we learned in algebra. It's a two-variable system of equations. So we don't have anything here that's readily isolatable. I guess you could divide the entire top one by 2. But what I'm going to do is I'm going to multiply the top by 2 and the bottom one, or top equation by 3 and the bottom one by a negative 2. Now what this is going to do is it's going to allow me to eliminate my x's. So that goes 6x, not literally eliminating x's is illegal, but algebraically it's fine. So it goes 6x plus 12z equals negative 12. The bottom equation then becomes negative 6x minus 10z equals negative 6. Add those two together, we get 2z equals negative 6, or z equals negative 3. Okay, so now what we're going to do is we're going to take that negative 3 and we're going to plug it back into an equation that only has z and one other variable. Like that one right there, 3x plus 5z equals negative 3. 3x plus 5 times negative 3 equals negative 3. 3x minus 15 equals negative 3. We're going to add 15 to both sides and we get 3x equals 12. Divide both sides by 3 and we get x equals 4. So now we have our x is 4 and our z is 3. So we can plug those back in to any of the original equations. So we have 4 minus y minus 3 equals negative 1. We are then going to say that gives us 1 minus y equals negative 1, or y equals 2. Subtract negative 1 here. We'll go subtract 1 from both sides, so we get negative y equals negative 2. multiply both sides by 1, we get y equals 2. So that gives us our xyz of, our x is 4, our y is 2, and our z is negative 3. Okay? So the next one I'm going to do, and I don't remember what problem this is. It's negative 2x plus y minus z equals 2. Negative x minus 3y plus z equals negative 10. And 3x plus 6z equals 24. So you know I had a little bit of trouble with this. And I'll show you kind of how many times I actually ended up doing this a couple times. No, this wasn't the one. This one, I think I did fine on. Here, let's check. No, this is the one. So what I'm going to do is I'm going to start off by getting rid of my z's up top. So I have 2x plus y minus z equals 2. And negative x minus 3y plus z equals negative 10. So those two I can just add together. 2x minus x is x. Negative 3y plus y is negative 2y. And negative 10 plus 2 is negative 8. Okay, now this next one's a little bit trickier because I'm going to move that top one down. So I have negative 2x plus y minus z. Oh, looks like I dropped. Oh, that's what I did. So when I first did this, I wrote it down as 2x instead of negative 2x. So that threw me off, and I had to. So I actually worked the entire problem, and then was going back and checking my answers, which I do because I want to make sure I did it right, and realized that they weren't coming out right. So I went back, checked my work, and saw that I had actually written the problem down wrong. So that's why it's good to always check your answers. So we have negative 2x. Whoa. I'm on the wrong one. Okay. So here we are. So we have negative 2x plus y minus z equals 2. And then we have 3x plus 6z equals negative 24. So what I'm going to do is I'm going to multiply the top equation by 6. So that's going to give me negative 12x plus 6y minus 6z equals 12. So 3x minus 12x gives me negative 9x. 0 plus 6y gives me a positive 6y. 6z minus 6z is 0. And negative 24 plus 12 is negative 12. So that's my second equation. Okay, so now those are my two equations. I've got an x and a y and an x and a y. So again, this is just back to Algebra 1 to find that x and the y. So what I'm going to do is I'm going to multiply that top equation by 3. That's going to give me a negative 9x minus 6y equals negative 24. I'm going to add those together. It's going to give me negative 18x equals negative 36. Divide both sides by negative 18, and I get x equals 2. Plug that back into that equation right there. I get negative 3 times 2 minus 2y equals negative 8. That gives me negative 6 minus 2y equals negative 8. Negative 2y equals negative 2, or y equals 1. So now, what I could go and I could plug the x and the y back into the top two equations. But what I'm actually going to do is I'm just going to plug the x into this equation right here. Here, this one right there. Okay? And the reason for that is that it's only got two variables. So if I plug the x in there, I then just have to isolate my z. So we got 3 times 2 plus 6z equals negative 24. That's 6 plus 6z equals negative 24. I'm going to subtract 6 from both sides. So that's going to give me 6z equals negative 30, or z equals negative 5. So then I can go 2, 1, negative 5. Now I'm going to quick check my work. So what I'm doing is on this second equation right here, I'm going to go 2, so that's negative 2, minus 3, plus a negative 5. So negative 2 minus 3 is negative 5. Negative 5 minus 5 is negative 10. So that checks. So I know I did it right. I could have done it on the top one too. I could have gone... So negative 2 times 2 is negative 4, plus 1 is negative 3, minus a minus 5, 3 plus negative 3 plus 5 is 2. So that checks as well. Okay? So we know we did it right. Now, just so you know, I did this a couple times, and that's what it looks like. So I had to actually go back and redo it, because like I said, I did it wrong. I got the... Because I knew I had the wrong answer, I was able to go back and do it. How did I know that I had the wrong answer? I checked my work. Always important. So, last one, I think, was elimination. So this is 3, again, so those are my equations. So what I'm going to do is I'm going to take those bottom two, and I'm just going to add them together. That's going to get rid of my z's. Okay? So I have 3x minus 2y equals negative 2. This is the same one, isn't it? This is the same one? No, it's not. So it's going to be 3x minus 2y equals negative 2. So then I'm going to bring down that top one and look at those bottom two, or the top and the bottom one. Okay? So what I have here, and again, I got rid of the z in the first place, so I'm actually going to multiply that bottom one by negative 2. Okay? So that's going to give me... Oh, that's what I'm doing. I'm taking the top one and the middle one. So 3x plus 2y plus 2z equals negative 2. And then I'm multiplying that second one, the 2x plus y minus z equals negative 2. I'm going to multiply that by 2. That's going to be 4x plus 2y minus 2z equals negative 2. Add those together, I have 7x plus 4y equals negative 6. Add those together. So now I'm going to multiply that top one by 2. Yeah, it gives me 6x minus 4y equals negative 4. Add those together, and I get 13x equals negative 10. And then x equals negative 10 thirteenths. And at this point, everybody groan. I can hear you groaning all the way at my house. It's okay. Yes, that is the right answer. I actually was so concerned that it was the wrong answer that I actually pulled out the teacher's edition, checked to make sure x does equal negative 10 thirteenths. So there are a couple ways you can go about this. So when you plug this in, like this, so I'm plugging this in to this equation right here, okay? So there are two different ways to do this. And I'm actually going to, I originally did it using the fractions. I'll show you that. So we multiply negative 3 by 13, add 30 thirteenths to both sides. We get negative 2, woo! We get negative 2y equals negative 26 over 13, plus 30 over 13, negative 2x equals negative 4 over 13. Divide both sides by negative 2. And we get y equals negative 2 thirteenths. Now that's also correct. I'm going to show you a slightly different way to do it though. Okay, so we start here. We get here, okay? And now what I'm going to do here is I'm going to multiply the entire thing by 13. And that's going to clear my fraction. So now I'm going to have negative 30 minus 26y equals negative 26. I'm going to add 30 to both sides, and I get negative 26y equals 4. Divide both sides by negative 26. And I get y equals negative 4 over 26, which reduces to negative 2 over 13. So we know that's the right answer. So that's probably easier. So whenever you have a fraction like that, multiply it by the denominator, and that's going to clear that fraction. Did the same thing here. So now we know that my x is negative 10/13 and my y is negative 2/13. I'm going to plug that into my middle equation because that's the one with just a z hanging out. So I have 2 times negative 10/13 minus 2/13 minus z equals negative 2. So that's what I get by plugging them in. I'm then going to, again, I can sit there and kind of do the whole thing like that. And work it through, and get z equals 4/13, which is correct. Or what I can do is, once I have that set up right there, I can multiply everything by 13. So I have negative 10 plus 6 plus 13z equals 0. That gives me negative 4 plus 13z equals 0. 13z equals 4, or z equals 4/13. So even doing that, I get the same ordered triplet. Okay, I would get negative 10/13, negative 2/13, and 4/13. I think for a lot of you, doing it like this, clearing the fractions, is going to be easier than it was doing it like this, keeping the fractions alive. Okay? So, this next one, this is the first one from the substitution one. So I think it's like 21 or something like that. So they went super easy on you. So they give you z equals 2, y plus 2z equals 0, and x plus 2y plus 3z equals 6. So this is super easy. Excuse my yawn. We're going to take that z equals 2, and we're going to plug it right back into the equation right above it. So we have y plus 2 times 2 equals 0, y plus 4 equals 0, or y equals negative 4. So we're looking for an x, a y, and a z. We've already got our y is negative 4, and our z is 2. So we're going to plug both of those back into the top one. X plus 2 times negative 2, plus 3 times 4, 2 times negative 4, 3 times 2 equals 6. That gives us x minus 8 plus 6 equals 6, or x minus 2 equals 6, or x equals 8. So our ordered triplet is 8, negative 4, 2. The problem with this is it's really tough to check your work. But that's right. So the reason you can't check your work is because you don't have multiple equations with multiple variables. Your z is 2. So the only way you can check that, you're kind of given that. You can put your y and your z, so you can go negative 4 plus 4 up here equals 0. And then you can plug in here 8, negative 4, and 2. But since you already just did that and that's how you got it, even if you were wrong, you should end up with the right answer. I know that sounds silly, but problems like this are tough to check. Next, so this is another one that I ended up doing multiple times because, I don't know, I forget why. Oh, I actually did it right but wrote the answers down wrong. So I ended up doing it twice. So here, what I'm going to do, this is substitution. So notice here we have RST. So we have 5R minus 4S minus 3T equals 3. We have T equals S plus R. We have R equals 3S plus 1. So first things first, I'm going to take that R and I'm going to replace that R in the second equation with the 3S plus 1. So that gives me T equals 4S plus 1. Okay, I'm then going to take the R and plug it into the first equation. 5 times 3S plus 1 minus 4S minus 3T equals 3. 15S plus 5 minus 4S minus 3T equals 3. And that's going to give me 11S minus 3T. Then I'm going to subtract 3 from both sides, so I'm going to get negative 2. So those are my two equations. Now what I'm going to do is I'm going to take that 4s plus 1 and I'm going to plug it back in to the equation we just got. 11s, and again, I know my s's and my 5's look alike, and I'm sorry. So 11s minus 3 times 4s plus 1 equals negative 2. So I have 11s minus 12s plus, see, I wrote minus 3 there, minus 4 there, and that was my original mistake. So I did the whole thing with that minus 4 there. Kitty cat. My Lele came to say hi. Here, you can hear her purr. I'll put her up and you can hear her purr. Come here. Wasn't that exciting? Okay. So, see, I went 3 times 1 is 4, which it isn't. It's 3. But, so I went through and I did the entire problem and I solved S with that and it was wrong. So I was able to go back, though, and check my work because when you check your work, you know whether or not you got the right answer. So I have negative S minus 3, so I added 3 to both sides, so I get negative s equals 1, or s equals negative 1. I'm then going to plug that back into that 4s plus 1 equation. So I have 4 times negative 1 plus 1. That gives me negative 4 plus 1, or t equals negative 3. So now I can plug my r, so I know r equals 3s plus 1. So r equals 3 times s, negative 1 plus 1. R equals negative 3 plus 1, or negative 2. So that gives me all 3 of my variables. So negative 2, 1, negative 3. Now I can go and I can look and make sure that that adds up. So I look at my second equation. Does negative 3 equal negative 2 plus negative 1? Yeah. If I look at that top equation, I go 5 times negative 2. That gives me negative 10. Minus 4 times negative 1, that's negative 4 times negative 1, or a positive 4. And then I have negative 3 times negative 3, or a positive 9. So negative 10 plus 4 is negative 6. Negative 6 plus 9 is 3. And that's what we have, so that checks out. So I know I did it right. And this is the last one I'm doing. So this one I'm going to do twice. So this is technically a substitution problem. So I'm going to do it by substitution, okay? Actually, I'm going to do it by elimination first, okay? Just to show you that you can do it both ways and you'll get the same answer. So if I do this with elimination, I'm going to add those top 2 first. So I get 5x plus x is 6x. I have 2y plus negative y is y. Z's cancel out, equals 9. And then I'm going to multiply that second equation by a negative 3. It's going to be a negative 3x minus 6y plus 3z equals negative 15. Add those up. 2x minus 3x is negative x. 3y minus 6y is negative 3y. And 5 minus 15 is negative 10. So those are my 2 equations now. 6x plus y equals 9, and negative x minus 3y equals negative 10. I'm going to take that top one, multiply it by 3. It's going to be 18x plus 3y equals 27. Add those 2 together. 18x minus x is 17x. 3y minus 3y is 0. And 27 minus 10 is 17. And lo and behold, I get x equals 1. Plug that back into 6x plus y equals 9. So I get 6 times 1 plus y equals 9. 6 plus y equals 9. Or y equals 3. Go and plug that back into x plus 2y minus z equals 5. I'm looking for z now. So I have 1 plus 2 times 3 minus z equals 5. That's 1 plus 6 equals 5, minus z equals 5. 7 minus z equals 5, or z equals negative 2. Subtracted 7 from both sides, so I have negative z equals negative 2. Multiply both sides by negative 1, I get z equals 2. So that is my answer. So that's using elimination, even though it said to use substitution. As long as you guys are getting the right answer and doing it mathematically correctly, don't care how you're getting it. Okay, you can use either process. So notice, if I go 5 times 1, that's 5, minus 3, plus 2. So let's see, 5 minus 3 is 2, 2 plus 2 is 4. Check. If I did on the second one, or look at the third one, so I have 2 times 1 is 2, plus 3 times 3 is 9, minus 3 times 2 is negative 6, should equal 5. 9 plus 2 is 11, 11 minus 6 is 5. Check. Cool, so I'm done. So, now watch this. Same one, but I'm going to solve that top equation for z. Okay, so I subtracted, I isolated the z, so I have z equals negative 5x plus y equals 4. Okay, I'm going to solve that second equation, so then I'm going to go in and I'm going to plug that in for my second equation. Okay, see what I just did? So I took out the z and I wrote 5x plus y equals 4. I'm going to distribute that negative, and I have x plus 2y plus 5x plus minus y minus 4 equals 5. X plus 5x is 6x. 2y minus y is y. And I'm going to add 4 to both sides, so it gets rid of the 4 on the left side and turns it into a 9 on the right side. So, I'm now going to do the same thing. Now I'm going to plug in that negative 5x plus y plus 4 into the bottom equation. 2x plus 3y minus 3 times negative 5x plus y plus 4 equals 5. I'm going to distribute that negative 3, so I get 15x minus 3y plus 12 equals 5. Now I just got a little excited because, hey, look at that, guys. I have a, not only did I get rid of my z by elimination, I have this 3y minus 3y. So the y's are going to cancel out too. It made my job so much easier. So I'm going to go 2x plus 15x, 17x, minus 12 equals 5. I'm going to add 12 to both sides. I get 17x equals 17, and x equals 1. Plug that back in to 6x plus y equals 9. 6 times 1 plus y equals 9. 6 plus y equals 9. Y equals 3. Plug in my 1 and my 3. 5 times 1 minus 3 plus z equals 4. 5 minus 3 plus z equals 4. 2 plus z equals 4. And z equals 2. So my ordered triplet is 1, 3, 2. Hey guys, check it out. 1, 3, 2, 1, 3, 2, 1, 3, 2, 1, 3, 2. So it doesn't matter whether you do it by substitution or elimination. If you're careful with your maths, it'll be right both ways. Hope this was helpful. Have a wonderful evening. Hope you guys do well on the homework, and I'll see you tomorrow.